derivatives of composite functions. So they've given you an explanation here saying that if h of x is a combination of a function within a function, okay, then the derivative is the derivative of the outer function with the original function inside multiplied by the derivative of the inner function, which is very, very similar to the chain rule. Okay? So they've gone about solving this in your book this way, and I'm going to show you a second way to solve this. Okay? So the idea here is this is our outside function. There you go. This is our f at x, and this would be our g at x. So according to this, if this is our h at x, then it says that the prime of x is equal to the prime of the function with g inside, so 2x, multiplied by g prime x. Okay. Now, we can do this using two different variables. We could find with this variable u, and then with a variable x, and we could leave the function with two different variables and solve for when x is equal to 4 in both. Or what we could do is we could do a little bit of substitution, which might make this longer but simpler to look at. So we'll do it using their way, and then I'll show you a logical way, or what seems maybe like a little more logical way of doing this. So according to what we have above, we need to find the function or the derivative of our first function f at x, which is this one here. So I'm going to leave it in terms of u. I'm not going to change it to x yet. And what we're saying here is y prime is equal to, the derivative of this function here is just 3u squared minus 2. Okay? And that there is our f prime x. The only thing is I haven't subbed in g at x within this function. I can do that after. This is our g at x. And then it has to be multiplied by the derivative of g at x. Well, the derivative of this, and I'll do it on the side and then write the simplified version here. The derivative of this here is essentially 2x to the half. Okay. So using our chain rule, we bring a half down. What's a half times 2? 1. So we have x to the negative half, which is written as 1 over root x. So here we have 1 over root x. So now we have this in two different terms. Okay. I can now plug in my 2 root x in for my u, and then simplify from there if we like. So we have y prime is equal to 3 times 2 root x squared minus 2 multiplied by root x. When we go to simplify, this squared is 4x. 4x times 3 is 12x. Are we okay with that? That becomes 12x when I simplify that. Subtract 2. And because we're multiplying fractions, this becomes the top of the fraction, and the bottom just becomes the root x. So we get root x here. So this is a pretty much as far as we want to go. They said we want to find the value of x when it was equal to 4. So we would plug 4 in for our x value. Okay. 12 times 4 will give us 48 minus 2. It's 46. And the root of 4 is 2, which gives us a value of 23. Okay. This could be somewhat confusing, so I can show you another way that's a little longer and seems a little more logical. What I'm going to do is I'm actually going to substitute in my g at x to start in this question. Okay, so if we recall, the original function was y was equal to u cubed minus 2x, 2u, jump up, plus 1. Okay. And they had told us that u was equal to 2 root x. So instead of doing it the way they laid out there, we had to learn a whole other formula. I can just plug this in for the value of u. So let's go about doing that. U is now equal to 2 root x cubed minus 2 times 2 root x plus 1. This gets rid of us now having to memorize the derivatives for a composite figure. And we can just simplify this and find a derivative the way we were used to doing in the last few lessons. So I have it as is right now. I'm going to simplify the middle, but I'm going to leave this as a chain. So y is equal to 2 root x cubed. This just becomes minus 4 root x plus 1. Okay. So now let's find the derivative. Y prime is equal to, we bring down the 3 in front, times 2 root x squared. And then we have to find the derivative of 2 root x. Do you guys remember what it was? By chance? No? Yeah, so it's 1 over root x, but I'll show you again if you're unsure again. We had 2, remember, to the half. So using the chain rule, a half times 2 is just 1. So we're left with x to the negative a half, which is essentially 1 over root x. Okay, so the derivative of the inside of that function is 1 over root x. So that's the hardest part of this, deriving that first function there. From there we have subtract 4 root x. We'll do the same thing over here. 4 root x is the same as 4 times x to the power of a half, which becomes 2 x to the negative half, which becomes 2 over root x. So once we understand this part should make sense quickly at least. 2 over root x. And the derivative of 1 is value of 0, so we add 0. It doesn't really include itself. So now we're working with these two functions. Y prime is equal to, let's do a little simplifying. This here will become what? If 2 root x times 2 root x is just 4x, correct, good. So we have 3 times 4x, and then technically times 1. Okay, so because these are multiplication, it's like multiplying fractions. All the top numbers by each other, all the bottoms, we get over root x. Subtract 2 root x. 3 times 4x is 12. So we get 12x. And because the denominators are the same, we can all put this over one denominator of root x. So 12x minus 2 over root x. And if you recall, that's what we got way back here. Whichever way you feel is easiest for yourself, feel free to use. If you find it easier to plug everything in, that can be simpler, but there was a little more complex when finding our derivatives. Here, we use the composite of derivatives, and we're able to do it. Yes, go ahead.